Science and gambling have always had a very intertwined relationship. There are many great mathematicians throughout history that got fascinated by gambling, but few of them have really managed to come up with an idea powerful and innovative enough to make them rich. So, in today's video, we are going to explore a little bit the math of games of chance. Or, put another way, here's how mathematicians and physicists in the 20th century made their way to Las Vegas and finally managed to beat the dealer. Probably one of the most famous and iconic games in Vegas is Blackjack. The rules of Blackjack are quite simple. Each card has a certain value, from 1 to 11. You can draw as many cards as you want, trying to get a count as close as possible to 21, but not over. To win, you have to score more than the dealer. If you go over 21, you lose by default. Blackjack is obviously a game of chance, because cards are drawn randomly, but it also involves some strategy, because it is up to you to decide when to draw a card or when to stop, and also how much to bet. And if you think about it, also the draw of a card is actually not completely random. In Blackjack, as in many other card games, cards are normally not reshuffled at each turn. Instead, the dealer continues playing until there are enough cards to play. Well, if some cards have already come up, then they won't come up again until the deck is reshuffled, right? Consider a 52 card deck with 4 aces. The probability of drawing an ace in the first round is 4 divided by 52, which is almost 8%. But if 10 cards come up in the first round, and 2 of which are aces, then the probability of drawing an ace in the second round is only 2 divided by 42, which is less than 5%. Now you'll say, alright, but what if we consider more cards? It doesn't make sense to keep track of all cards and calculate each time all possible combinations. You need a way to quickly understand whether you have an edge over the dealer or not, based on the cards that have already come up. This was the real problem that mathematicians had been trying to tackle for centuries. Remembering cards is not enough. You need to know how to use the knowledge that you gain from cards counting in the most efficient way. The answer to this problem was found by the mathematician Edward Thorp in the 60s, with the help of Claude Shannon, another mathematician and also known as the father of information theory. Information theory was exactly the discipline that gave Thorp the answers on how to win at Blackjack. Information theory is the science that studies and quantifies information, connecting information to probability and frequency. For example, have you ever played Scrabble? Well, the points assigned to each letter in Scrabble are different for every language, and are determined in each language based on the principles of information theory. In the English language, for example, the letter Z is less frequent than the letter A. Scientists would say that the Z carries more information than the A and is thus assigned a high score. Information theory was the missing link between game statistics and winning strategy. All techniques of cards counting used today are just information theory applied in a very specific way. Okay, now suppose you run the numbers and discover that at a particular moment in the game you actually have an advantage. And you are even able to quantify this advantage. How much money should you bet exactly? Let's leave Blackjack for a moment and consider a more simple game, a coin toss. If it comes up heads, you win $10. If it comes up tails, you lose $10. It sounds like a fair bet, right? Mathematically speaking, a bet is considered to be fair when, if you play the same game multiple times, on the long run your total gain is 0. And this is true when you flip a coin. If you play many times, you will expect to win and to lose a similar amount of times. So, if you really think about it, you won't be able to win that much at this game. Now, imagine that you come to know, for some reasons, that the coin used in the game is not perfectly balanced, and that the chances are not 50-50, but rather the probability of heads is 60% versus 40% for tails. So you actually have some edge over your opponent. How much would you bet now? You might consider to bet more than $10 in this case, maybe 30 or 50. But your intuition also tells you that you should probably still not bet your own house on this game. And your intuition is absolutely right. But why? What is, from a scientific perspective, the best amount of money you should bet with this level of advantage? The solution to this problem was proposed by John Larry Kelly, and American physicists. Kelly found that in order to exploit some partial information that gives you some small advantage, you must bet a portion of your money according to this formula. Probability of winning minus the probability of losing divided by the odds, aka the payout. In our example, the payout is 1, since you risk $10 and win $10. The win and loss probabilities are 60% and 40%, so you should bet 20%, that is 1/5 of your entire bankroll. If you bet so much, Larry's criterion ensures that you won't go broke, and you'll maximize your wins in the long run. Of course, in games where the number that comes out of this formula is 0 or even negative, you should not play at all. This is the typical situation of someone who plays roulette or the lottery without having any advantage information. And a similar story holds true also for Blackjack. If you want to use the Kelly criterion in Blackjack, you'll need to count cards, learn how the composition of the deck changes at each round, and use information theory to come up with an accurate estimation of your advantage over the dealer. Based on this estimation, you can use Kelly's formula to determine whether and how much of the money at your disposal you should bet. Well, technically, it is not only from card counting that you can get useful information. For example, even in the way of shuffling the deck, there is an amount of information that gets preserved. In 1966, Thorp published a book, Beat the Dealer, about the exact process of his strategy. The book quickly became a bestseller, and card counting immediately sent many casinos into crisis. So much so that card counting has become illegal in many casinos today. Besides, casinos today use multiple decks, which makes cards counting basically impossible. But the principles of information theory do not apply only to blackjack, but to virtually all games, from roulette to horse racing, even to the largest casino in the world, the stock market. Well, no wonder if in addition to his book, Thorp is now famous for being one of the most successful hedge fund managers in history. He achieved an unprecedented 20% return per year, and his personal net worth is almost $1 billion. Not bad, right? And this brings us to the conclusion of today's video. I hope you all had a great time. And if so, feel free to share any comments and to watch other videos on this channel. Stay tuned and don't forget to like and subscribe.